Hello everyone. So today in this grenade throwing mechanism, we are going to look into how to show this predicted projectile path, as you can see in this demonstration. So we can get an idea of where the grenade will hit if we throw. So let's see how to do that today. And this episode is sponsored by these generous patrons. Thank you very much for your support. Right, now that we have worked on this animation part, the next thing is showing an arc that predicts the projectile path of the grenade. So, okay, for that, let me open. This is the base character of the ALS base character. Now here I am going to add a spline mesh dynamically that mesh the predicted projectile path to show where the grenade will hit if we throw. So for that, first I need a spline. Let's add one here, and I'll add a custom event. Show projectile path. So this must be executed only if throwing is true. Let's call this here show projectile path. Shall we collapse this part? Otherwise this part would become a lot bigger and everything will be not clear. Right, now here we can do this. There is a node predict projectile path by trace channel. So there are three ways to predict projectile path. I am going to use this by trace channel. So we have to give the starting position and the launch velocity. So where should it start? So let's add a scene component, and we do somewhere like here. I think here should be fine. Let's call this scene component projectile start. So I'll access this get world location. This is the starting point and the launch velocity. So this should be, for the player, this should be always based on the direction that we are trying to aim. So let's get control rotation. From this we can get the forward vector based on this control rotation, and let's multiply with this value because this would be a unit vector, I think. Yeah, so let's try something like 1500 and use it as the launch velocity. As the trace channel, let's use camera and actors to ignore. Let's add self. We need to ignore this character itself. Okay, now how do we visualize this path? Let's do for each loop and debug point. Let's draw a debug point here, but does this return the in local space or world space? I'm not sure. So let's just set 20 point color red. Let's draw these points and see what do we get. Alright, we get the positions, but it doesn't change as we look around. That's because this is rendered only once. I'll set this to 0.1, let's say, or we can get delta seconds, world delta seconds, and have a delay of the same amount, and call show projectile path again. So this will be refreshed each time we look around. And it doesn't. Why is that? Oh, maybe we need something larger. Let's set 1 second. Right, now it updates the path, but that's not very clear because the path is always blocked by the character. So to avoid that, we can add something to this vector. Let's say point percent in Z direction, so the arc will always start a little bit upward so that we can clearly see it. See, like this. Okay, better. Alright, now we have an idea how this arc would be. Now to properly demonstrate that, let's add a spline mesh. And to add spline meshes, actually for a spline mesh component, all it has is a starting point and starting tangent and end point and end tangent. So we need to have a sequence of spline meshes in order to visualize the projectile path. But in order to calculate, we need to have we need this spline component. That's in order to calculate those tangents and everything. Otherwise we will have to manually calculate them. So that's why I add this. So I'll name this projectiles line or projectile path. And instead of drawing these debug points, I'll get the projectile path at spline point at index, and index is this index, position is this position. space is local. Right, so once we have the projectile path, we can access the tangents of each spline point. So using those data, we can add spline mesh components. So for that, let me break this and put it aside. So after initializing the projectile path, and remember, initially, before adding anything to projectile path, because this function will be called again and again, so we need to clear the path spline point in this path as well. But we don't have to worry about that. Let's add a loop here, a for loop. Starting index would be 0 and ending index should be projectile path get number of spline points minus 2. The reason I added 2 is when I add a spline mesh component, we have a starting point and an end point, and the number of the final index of the spline point would be the number of spline points minus 1. And also if there are 10 spline points, there can only be 9 spline mesh components. So the final index should be the number of spline points minus 1. So each of these index we can add spline mesh component. So as the spline mesh component, I am going to use this simple cylinder. I have already imported that. This is actually nothing fancy. Spline beam. This is a very small. Where is it? This is a very small cylinder. Nothing else. You can use. You can just simply use any cylinder you have, but you may have to set the scale correctly. I'll set it to manual attachment, and then we have to set start and end. So these are the things we need. As I said before, we need the starting position and end position and start tangent and end tangent. So again, let's get a reference to projectile path. Get location at spline point. First location would be this index, and the end location would be this index plus 1. And the tangent. That also we can access it like this. Get tangent at a spline point. First tangent is the index, second tangent is index plus 1. Right, and I'll select, I forgot to select spline beam. Okay, since I don't call it again, this will only be drawn once, but let's see if this works up to now. It does. You can see this projectile path, but it is not updated because I am actually not updating that. So once this is completed, we can call this, so it will be updated, but we will have a problem. We don't have a way to delete this already added spline components yet. So that means we will have a lot of spline components. See, and that affects the performance as well. Right, so what we can do is these spline mesh component object references. Let me promote this to a variable. Components. Let me break this. Where is it? I'll put it under throwing. I'll turn this into an array. And then let's get a reference here. Add each spline mesh component we create to this array. Then at the beginning, let's get this projectile path and clear spline points. Let me collapse this. Clear path. So we need to clear the spline point, and also we need to clear all these spline components. So actually it would be better if we, instead of just deleting and recreating, if we reuse it like object pooling, but let's just do it this way and see if that affects performance. So all of these elements should be destroyed. Destroy component, and after destroying we need to clear this array as well. Okay, now let's see. Cool. Now we have the projectile path. But I think the starting location could be a bit higher. To match the hand. Yeah, that's better. shall we make this a little bit brighter? Because it's not very clear in this background. Yeah, now it's clear. You can easily see that. Okay, so we forgot to clear that after we throw in the grenade. Right, so that means this clear path should be called regardless of we are throwing or not. That means we should put it before the check. See? Great. Okay, now we have the projectile path that shows the location where the grenade will be hitting, and next time let's implement the actual grenade, how to throw it and how to explode it and how to make it affect the nearby characters. And thanks for watching. So as always, project files will be available for the download in Patreon page. Link would be in the description below, and if you like to support my work, you can get the membership of the Patreon club. See you in another episode. Goodbye.